Data is the new oil, they say. But, unlike oil, you cannot pump data through a pipeline. Actually, sharing data across different recipients and across companies is not an easy task. If you speak to a vendor, they will tell you that if you buy another one of a vendor system, you can share data to the new system. And of course, you have to pay for a new license. But how about sharing data in a more open way using open source and open standards so that you can access the data using the most popular open source platforms in the world, such as Pandas or Apache Spark? Well, welcome to this session about delta sharing. So the title of this session is Sharing Huge Amounts of Live Data with Delta Sharing. And wherever you are, this session is coming to you from Munich. I'm Frank Munz. I work for Databricks as a developer advocate. Databricks is the data and AI company, the original creators of Apache Spark, MLflow, Koalas, Delta.io, and the brand new Delta Sharing. Now, I'm based in Munich, and my background is in high-performance computing and data science and cloudy things. I'm interested in all kind of things, large-scale data and compute. So actually, part of my job is to expand the community in EMEA. And we just launched a brand new forum for Databricks. You can get there if you go to community.databricks.com. We have a program which is called the Beacons program. Now, the Beacons program is like the AWS Heroes program or the Microsoft MVP program. It's a program where we try to honor people that are very active in the community, that speak at conferences, that help the community, that share their knowledge. And talking about community, we also started about 10 new meetup groups throughout Europe, Middle East, and Africa. And this is where you become even more important because we want to hear from you. If you've done any cool project, if you worked with the open source frameworks that we are working on, if you have something to talk about, please don't be shy. Contact me. We're always looking for good speakers for all kinds of events and for local meetup groups. So the title of this talk is Sharing Huge Amounts of Data with Delta Sharing. Now, think about for a second, where is huge amounts of data coming from? Well, it's coming from a lakehouse. If you don't know the concept of a lakehouse, the lakehouse is the best of both worlds. If you take a data warehouse and you merge it with a data lake, what you get is a lakehouse. Now, the data warehouse is an excellent platform for running SQL workloads where you go from OLTP to OLAP, and actually workloads where you want to create something like BI dashboards or reports, where you want to look backwards into the past, where you want to understand about what happened in your business, like in the last month or in the last quarter. And such platforms are great. They provide structured data, SQL access, you have a schema with your data, but they're not so good for machine learning and they're not so good for unstructured data. And this is why people love their data lakes. And this is where you can put like virtually unlimited, highly available, cheap storage, where you can use cheap storage and you put your data on such a cloud object storage. And that's the data lake. And the data lake is the fantastic platform for running machine learning applications. And if you take both together, we have the lakehouse. So the lakehouse is one platform for BI, for reporting. It works for data science, for machine learning, streaming, for all your data. One platform for all your data. What we want to do is we want to simplify the data management platform with the lakehouse. Then a lot of people say, well, if this is open source, is it used at all? Do you have companies, like big companies, using that? And the answer is yes, across all the industry, be it like food, for example, McDonald's, be it like energy, for example, Shell, be it automotive, like Ford, be it finance, like ABN AMRO. There is actually no vertical where the lakehouse today is not used. And delta sharing. Well, delta sharing, it's open source. You can get it from GitHub. If you go to github.com/delta.io/delta sharing, you get to delta sharing. It is using an open format and it's vendor independent. Because it's so simple and yet powerful, it is automatically multi-cloud. It uses the Cloud Object Store, so you have the bandwidth also of the Cloud Object Store. And on the client side, you can use Pandas or Apache Spark to access delta sharing servers or shared data with delta sharing. You can also use commercial clients like BI clients such as Tableau or Power BI. And to run a delta sharing server, you have different options that I want to explain throughout this presentation. You could host a delta sharing server yourself using a pre-packaged sharing server that you just get from the download site. You can run it from a Docker image as a Docker container, or you could use the Databricks service where we include a delta sharing server in your account. So to recap again with this diagram, we have the sharing server, which you see in the middle. Could be a Docker container, it could be the prepackaged sharing server. Both are open source. You can get to the sources, you can run them yourself if you like. You have the client. The client is Pandas or Apache Spark or any commercial client supporting the open protocol. Actually, the open protocol is a REST protocol that is documented. And the delta sharing server is accessing the data on S3 and is then handing out pre-signed URLs to the S3 objects. And with this, I already want to jump right into the very first demo. Now, the very first demo is the easiest approach that you can think about. It is just accessing an existing delta sharing server and retrieving data from the server, data that is shared with the clients. And to do so, what we do is we use Google Colab as a client because it's on the Google site. And what we also do is we access an existing sharing server on AWS that is hosted by Databricks. So even in this very small example, we have multi-cloud from the client to the server, and we can already show this. So if I switch now to Google Colab, I already have a notebook prepared here. And if I double click on that, you will see that this is actually basically what I explained to you. That's the Delta Lake table. There is a Delta sharing server that is hosted at Databricks. We do need access permissions, and that will be the part that I'm going to explain you later on in the code within the notebook. And there is this Delta sharing protocol, which technically is just a REST API. So even Spark and Pandas, those adapters, they use the underlying REST API. And for commercial clients such as Tableau or Power BI, they can also use this underlying REST protocol that is documented on the website. So if you go to the open source GitHub site, Delta Lake, and you go to sharing, GitHub, and then you can just check out the protocol here, and it's all documented. It gives you the REST API calls to list a share, for example, and how this will look like. Now I'm changing back to my notebook, and the first thing to get started with a notebook is I need to install, and this is what is happening here in the background, I need to install the libraries, the delta sharing libraries that my Python code at the end will need to talk to delta sharing, which is basically implementing the REST API that I just showed you. Now that happened already. Now in the next step, I import them. So I say delta sharing, I want to import them. And then things get more interesting. There is this profile file, which is actually pointing to an HTTPS location on GitHub. Now I retrieve the file, and with that file, I can create a sharing client. And with the sharing client, I can say sharing client, client and then list all tables. And that's what I want to do here. And let's see what is coming back from there. And you see that there is data coming back. So we can list existing tables on this shared server. Now to look at the file, I've done this before, but I run it for you again. The file looks like this. So this profile file, it contains the endpoint that the client is talking to. That's obviously important because otherwise you wouldn't know who to talk to. So that's the endpoint that is hosted at Databricks. And it also contains this lengthy bearer token. And with the bearer token, we get access. So the server is configured to require exactly this token. Now, once we have the client and we have the profile, we can load the data as a pandas table, which is happening here. And you've already seen above there is some COVID data. So the table name is COVID-19 from the New York Times. The share is Delta sharing, and the schema, which is basically the database, is the default database. So I'm loading the data at the moment, and this already happened. And then I want to display the first 3 lines, and I limited the ISO code to Australia. First 3 lines, it's Australia, Oceania, Australia. And then what I want to say is, well, take this data and plot it, and you see it looks like one of those typical corona infection curves over time. So this is new cases. And let me see if I plot total cases. You'll see this is the cumulative curve showing exactly the same. So to remember, what we've done here is we accessed data from a Google client. It was like super easy to get to the data. What we needed is this share file. In our case, we got the share file. Well, we got it from GitHub, but typically this is distributed to you. This share file, it's given to you, and it's created when the recipient of the share is created. So here, this is just a little trick, so I don't need to download the file to speed up things. Normally expect that somebody is giving you exactly this file. And then with the file, we can create a client, and with the sharing client, we can load the data as pandas or as Spark. I was showing you the pandas version. You could do the same, load as Spark, load the same data as a Spark data frame, and then not work with pandas, but work with the Spark syntax. And that was just like, yeah, to show off what we can do with the data. All right, now probably you're thinking, okay, that's interesting, but couldn't I have done some data sharing with FTP? Or couldn't I have done some data sharing with, going from one vendor product to the same vendor product in a different instance? Or if you understand about S3, there is something like you can have a URL for an S3 object and then share the object using the URL, using a get on this URL. Now, if we compare these options, now, obviously, from vendor to vendor, this is not vendor agnostic. It's not multi-cloud. It's not open source. It gives you a higher level of abstraction very often if you share from within a database instance to a remote database instance. You get this table abstraction, but that's it. Looking at SFTP, obviously, this is more open because it's a very low-level protocol. You could do it from Cloud A to Cloud B. So in some way, this is multi-cloud. There will be open source FTP. So in some way, this is more basic. It's more open. It's more multi-cloud. Coming back to the S3 URLs that I told you that we could use and share objects. Obviously, they're secure. They're cheap because it's using S3. And they do work at the object store bandwidth that we have from S3. and they have zero compute cost. You all know that at S3 you just pay for the storage and the I/O. But then if you look at delta sharing, it kind of gives you the best of all these worlds. So one thing that I find is very important that we don't emphasize often enough, you get this abstraction layer of having tables or data frames, which are more or less equivalent. One you can convert to the other. It is vendor agnostic, it is open source, it is multi-cloud, and it also does work actually with predicate pushdown. So you could specify what subset of data you're interested in, and then it would not read the complete table, but only a subset of the data. And it does come with zero compute cost. All right, and this brings us to demo number 2. All right, let's come to the second demo of this session. Now, in the first demo, we accessed data that lived on an existing delta sharing server that is hosted at Databricks. And now we want to host our own delta sharing server with our own data. Now, I prepared something for you, and I want to share some personal data, some of the most personal data that you could share, some of my genome, some of my DNA. Now, to do so, we're going to start our own server. And it looks like this. So that's the delta sharing server that we are going to start in a minute. And we are going to use an open source Jupyter notebook to access the delta sharing server. The data is on S3. Remember, we have this lake first approach where you just leave the data in your data lake. We are able to access the S3 storage from the EC2 instance where the server is running because I created a instance role that lets the EC2 access the S3 bucket. And the server itself is using a YAML file. The YAML file defines which share, schema, and table are mapped to what bucket. So this is the mapping from share, schema, and table to the S3 bucket. And talking from the client side to the server side, from the recipient to the data sharing, it's using a REST API. So under the hood, there is a REST API. The REST API is documented. You remember the profile share file? That's the same. It's specifying the endpoint and the bearer token to get from the client to the server side. Now, the interesting thing is that the server is retaining a pre-signed S3 URL to access the data, or multiple pre-signed S3 URLs with a short time to live to access the data. So the communication is not going through the server is not the bottleneck, but the client is directly getting the data from S3. The genetic code that I'm sharing are a few snippets of my DNA. You all remember from biology that your DNA is this double helix, and there is those base pairs like adenine, thymine, cytosine, and guanine, and they form those connecting bars in the double helix. And at certain locations in the DNA, which are called RSIDs or SNPs, the RSIDs, they encode the genotype. Now, the genotype could be AA, which means it's twice the adenine, or it could be like AG, it's adenine and guanine. And certain locations encode certain traits of your body and of the way your body functions. And there is one location, for example, like the RS12913832, that is encoding the color of my eyes. And that's one of those genotypes that we are going to check. They're shared by the delta sharing server, and then we use an open source Jupyter notebook to access them. Right, so that's the EC2 instance. It's actually running here, instances. That's the AWS console, that's the instance. Here you see the public DNS name with the 125. and that's the console. I'm already connected, and I can show you now the file, the config YAML file that specifies the server configuration. And you see that I have a share with the name share1, I have a schema, which is the database with the name default, and then I have 3 tables. One is cars, the other one is a full genome set, and the third one is a kind of restricted genome set of myself. So many years ago, I decided to have my DNA analyzed. You spit into a test tube, you pay a couple of $100, and you get back this structure, this tab separated value file that lists you the RSIDs together with the genotype. There is no bearer token that's commented out, and the server, the sharing server, is running at localhost 4x9. That's also the reason why I have a tunnel established. Don't worry about that too much. It's just connecting localhost 4x8 to the remote side. And I have the notebook server already running. And I will need this in a second to connect to it. But first of all, I want to start the sharing server, and the sharing server is started like this. So it's downloaded already, it's unpacked, it comes with the start script, it comes with a template of the config YAML file. You modify it the way I just told you, and then you start it, and it's starting up. It's sharing the specified buckets from the config YAML file, and this is what I'm trying to do. So let's go here again. That's the Jupyter server, and my notebook is under DNA. I'm loading this notebook, which takes a second. In the notebook, I'm loading the Delta sharing libraries. They're already loaded. Let's double check the share file. Again, you see it's pointing to localhost 4x9. That's the endpoint. It doesn't use a bearer token. Let's list the existing tables. Again, you see the cars, you see the genome, the Frank one, and you see the full one, which is some sample data that is publicly shared on the internet. Now, I use that to construct share default genome Frank, and I load the genome. If I look at the genome, that's an old run. It outputs the whole genome. It goes up to 638,000. That is the pandas way of accessing actually the trait that I'm interested in, the 129.13832 directly. That's a little bit playing with a statistics, a histogram over the genotype. Remember, I told you it could be AA or TT. That's the most frequent one. And then there is variations such as GT or whatever, and they're the least frequent ones. That's a plot over the SNPs that we analyzed per genome. Sorry, per chromosome. There is like 23 chromosomes, and you see them here going to 22, and that's the X and the Y. And there is one for MT for the mitochondria, which are the power cells, well, the power structures within your body cells, but they have a different genomic structure. Now that's a little helper function that I'm using to retrieve for a particular genome, for mine, with the existing RSID, the genotype. And that's what I'm going to run right now with my genome. So I say, well, give me this snippet back. If I run it, it says GG. There's something that is called SMpedia, which is like Wikipedia, but just for the human genome. And it tells you if you're looking for that SNP, and if the genotype is GG, like in my case, it says blue eye color 99% of the time. Now, I don't know if you can see it through the camera, but that's exactly right. All right. Let's go to coffee metabolism. And I have to tell you that I just had a coffee before I started this recording. And there is a study done. The return is AA. And the study examined like 8,000 people drinking coffee and studying their coffee metabolism. And the idea obviously is if your coffee metabolism is faster than normal, you're probably drinking more coffee to get to the same effect. Now, I am drinking a lot of coffee, and my value was, that's it, AA. And if you look at this, it says 0. AT would be slightly increased and TT would be slightly increased. So I have no genetic disposition for drinking more coffee, and I still do it. All right, and last but not least, there is something which is very influencer type of genotype, very social media publicity, very popular. It's called the warrior gene. It's this number. My genotype is AG. If you look it up in SMpedia, it kind of defines if you are more susceptible to pain, if you have an advantage in memory and attention tasks, or if you have some other traits, if you have lower dopamine, higher pain threshold, better stress resiliency. And my return is AG. That's the genotype which says, well, it's in the middle. So genetically, I'm kind of very boring in this respect. So I got the Delta sharing server as a pre-built package. And if I search for I get the pre-built package from GitHub releases. And the current version is 0.2.0. This is where I got it, then I unpacked it, and then I configured the config YAML file that I was just showing you. I started the server and I used the Jupyter notebook to access it. And this is kind of concluding my second demo. There is a few things more that I want to share with you. One is that reality isn't that easy. It's typically not one snip that determines a trait, but it's a number of snips together, and it's all about probability. And then there's something which is called epigenetic, which basically means that your genetic code is not like determining something, and it's impossible to change that, but there is a lot of influences that come from the way how much sport you're doing, how you're eating, what kind of stuff you're eating, how long your fasting period is, which determines what kind of genes are turned on or turned off, and this is called epigenetics. So at the end, I recommend you not to do that at home, because you might get some results that say, look, the probability for getting this kind of disease is like 3 times higher, and maybe you're not prepared to deal with that. So take it as an example that I was doing, but don't repeat that at home. In the third example, I want to show you 2 things. First of all, I want to show you how we can work with live data and delta sharing. So we have data that is shared, that is updated live. And the second thing is that you don't have to run your own server, your own open source server as a Docker container or as a download the pre-packaged server. What you can do is you can have delta sharing as a cloud service, which is part of your Databricks account. Now, let's look into that. Okay, so I'm not interested anymore in running my own server. I want to do everything from the convenience of my Databricks notebook. I go to Workspace. I select a notebook that I already created for you. It's this Create Share Bikes notebook. And what you see here first, it's using a catalog. So what I have here is a namespace, which is catalog, and then it's the database, and then it's the table. And I want to use the main catalog, which I'm doing now. Now I could create a database, but I have a database already. So I say use frankdb. That's the name of the database. Now I could create a table again, but I prepared the table already and I inserted some data. And I'm going to show you the data here. We do a select star from motorbikes. And we should see 3 motorbikes in this table, like rather old school but beautiful motorbikes. Now I can create a share using create share and the share name, but I already have this share. So I can say alter share, add table motorbikes. And if I run this, you will see that the share already contains this table. So creating a share is as easy as saying create share Frank Bikes. If I say describe that share, you will see it exists. And then I need a recipient. Now remember the profile share file that we were working with? To get to such a file, what you do is you create a recipient. Now I have a recipient already. I was running this before. It was named Frank, but I could create a new one and just call this biker friend and run this, and you see it returns a URL. It's actually an activation URL. If I copy it here, we can download the credentials file, and this credentials file is exactly the file that we were using in the client code. So I don't need it here. I want to go back to my notebook. I'm going to use the existing credential file that I already used. Now let's check the receiving side. For the receiving side, I go to a notebook that is running on Google Colab. In Google Colab, I need to pip install Delta Sharing, the client libraries. Then I need the file the share file, and that's actually the config fm share. And let's look at this. The config fm share file is pointing me to this endpoint. All right, so I import the libraries. I use the share file. With the share file, I'll create a sharing client. And then using the sharing client, I output the existing tables. So let's run this. And you see there is the table motorbikes, and that's the one that I'm interested in. Now I do something. I say Delta Sharing, load as pandas, and then give me all the motorbikes that are older than year 2000. And going back to this table, it should be number 1 and number 2. They're exactly those 2 bikes. Now this is shared data that I'm accessing on Google with Google Colab from a Delta Sharing server that is built into your Databricks account. And that you don't have to manage. That is a cloud service that is sharing data, and this data could be live data. So I'm updating the data. What I want to do is I want to say update motorbikes, and for ID 2, I set the year back to 1999. Let's run this. Takes a second. Then I change back. Remember we had 2 bikes here. I run the same command again, updated live data, and voila, you see it's only 1 left. Well, this is not a big surprise. It returns the whole table. We can do more expressions. That's the typical spiel we get with pandas. Give me all the motorbikes where the make is Honda, and so on. Well, that's it for this demo. What we have learned in this section is that instead of operating your own server, you can replace this with a few simple SQL statements. You can use Delta Sharing for live data. You can update data that is shared, and it will always be transactionally safe because of the underlying Delta I/O, because of the quality of service that you have in your lakehouse. Delta Sharing is built into the Databricks compute plane. That means it's available on an account level, and it's working for all your workspaces and notebooks. Actually, technically, it is a part of the Unity catalog. So to conclude, Delta sharing is a platform-independent, open source, open protocol way of sharing your data. You can share live data. It's transactionally safe. Clients can be Pandas or Apache Spark or a commercial client supporting the open protocol, such as Power BI or Tableau. You can use it from a managed notebook, Cloud9 or EMR or SageMaker or Databricks notebook. There is a pre-built reference implementation. You can have a Docker container. And the core message is that Databricks simplifies data and AI. And this is why we include a Delta sharing server in your account. How to engage? Well, the key entry point is Delta.io. From Delta.io, you can join the Slack channel. There's a YouTube channel. We have Google Groups. We have the new Databricks forum. You can submit GitHub issues, or you can join the office hours. If you have any technical questions that are not answered in this session, please use the brand new Databricks forum. That's community.databricks.com. If you want to learn more, you can follow my blog on medium.com. I'm on GitHub. Feel free to connect on LinkedIn. And I'm going to upload these slides on speakerdeck.com/fmunz. Thank you for listening and have a good day.